Static and dynamic friction. What is static and dynamic friction? First of all, let's understand what friction is, okay? Friction is a force that opposes relative motion, okay? It's a force that keeps a body in a resting position. It's a force that prevents a body from moving or makes a body to move or make a body keep moving. That's friction. So what does friction do? It prevents a body from moving or it makes a body to continue moving. That is what frictional force does. It's a force that opposes relative motion when two surfaces are in contact. So contact is required. So what is static friction? The types of friction, we have static, we have dynamic. Let's look at static friction. Static friction, when you say something is static, it means that thing is not moving. It's in one place, okay? Stationary, in one place. So static friction is a frictional force that prevents motion when a body is at rest. Remember, I defined friction in two ways. I said frictional force is the force that prevents a body from moving. That makes a body remain at rest. I said it's also a force that keeps a body moving. Okay? So that first definition I give, the first part of the frictional force definition is for the static friction. The frictional force that prevents motion when a body is at rest. Okay? It increases with applied force up to a maximum value, which is called the limiting friction. So when the limiting friction is higher, the object continues to be at rest. Remember, that friction is the thing that is limiting the body from moving. Okay? So let's look at dynamic friction. Okay, dynamic friction, also called kinetic friction. I'll explain to you what kinetic means earlier. Okay, moving. Okay, moving. So this is also known as dynamic moving friction. It's the frictional force acting when a body is already in motion. The body is already in motion, but this frictional force keeps the body in motion. Okay, because of this frictional force, that's what makes the body to continue moving. Usually less than limiting friction. So the dynamic friction is usually less than the limiting friction. That's why the object moves. So let's look at the key difference between the static and the dynamic friction. Static friction adjusts itself to balance applied force until motion starts, while dynamic friction is constant once motion begins. So static friction balances itself to what? Applied force. It adjusts and balances itself to applied force until the motion starts. But the dynamic friction is constant. So long as the object is moving, it's constant. Remember what limiting friction is. The maximum force value. That's the limiting friction. Coefficient of limiting friction. What is coefficient of limiting friction? Coefficient of limiting friction refers to the ratio of limiting friction F to the normal reaction. So the ratio of the limiting friction over the normal reaction. So this icon you are seeing here, this symbol is for frictional force, okay, or for friction, like U, okay, that's for friction, is equal to F over R, where F is the limiting friction, okay, then R is the normal reaction. So the coefficient of friction, the formula is F over R. I just told you what each of the symbols signify. How do we determine coefficient of friction? We determine it by placing a block on a horizontal surface, gradually increase applied force until motion just begins. Okay, so limiting friction is equal to applied force at that instant. So when the block on the horizontal surface begins to move, the limiting friction becomes equal to the applied force. So when an object is at rest, you need a maximum applied force to break the limiting friction. Okay, you need to continue to increase the applied force, increase the applied force until the friction, that limiting friction, is broken so the object can move. That's for the static friction. Then for the dynamic friction, the dynamic friction is usually less than the limiting friction. But in the static friction, you continue to increase the applied force to the maximum value until the object starts to move. So at the instant where the block starts moving due to the cumulative applied force, okay, that instant, limiting friction equals applied force. Advantages of friction. Jamb said we should be accustomed to these. Enables walking, grip between shoes and ground. Your shoe sole and the ground. It helps you walk. Number 2, allows vehicle to move freely. Traction between tires and the road. Friction enables writing, pen/pencil on paper. Now let's look at the disadvantages of friction. Of course, what have advantage must still have some varying disadvantages. Disadvantages of friction. The first, causes wear and tear of machines. Yes, because of the contact. After some time, it begins to wear. This can be reduced by lubrication. Okay, you add lubricant, is going to reduce the chances of wear and tear, or it's going to make the moving part or the part exposed to frictional force last longer. The second is friction produces heat, leading to energy loss. That's true. When two surfaces are in contact, there is contact and motion. It produces heat, and that leads to energy loss. That's true. Then the third one is reduces efficiency of engines and moving parts because of the heat produced. Okay, because of the heat produced, it reduces efficiency, and because of the high contact, energy is lost, so efficiency is reduced. We all know what affects efficiency in machines. We are going to treat that, of course. Reduction of friction. How do we reduce friction? Number one, use lubricants / oils / grease and so on. We use what? The ball bearing or rollers, okay, to reduce friction. We streamline our bodies, okay. You know what it means to streamline body? Make them smooth. That's why fishes easily swim in the ocean or in water, okay, because they have streamlined bodies, they are smooth. So streamlining body helps reduce resistance, okay. Polish surfaces to make them smooth. When you polish body surfaces, it makes them what? Smooth. This is also a method of reducing friction. Another method of reducing friction that is not here is applying powder, okay. Applying powder on a system or the body also help reduce friction. Okay. Viscosity and terminal velocity. What is viscosity? Viscosity is the internal resistance of a fluid to flow, okay. That thing that is preventing a fluid from flowing, okay, that's viscosity. I will also give you another simpler definition of viscosity. Viscosity can be defined as the frictional force that exists in fluid or in liquid, okay. The frictional force that brings the molecules of liquid or fluid together. Viscosity is that frictional force that increases the proximity of the molecules in a liquid, making it look thicker, okay. It looks thicker, more viscous. So the viscosity of a liquid is the measure of the frictional force that exists in the liquid, how close the molecules of the liquids are. Factors affecting viscosity. We have temperature, yes. Higher temperature equals lower viscosity in liquid. So when the temperature is high, viscosity falls. That's why when you use grease that is highly viscous, it's like a paste, okay. When you apply grease on a part of a machinery, when the machinery starts working and heat is formed, okay, the grease begins to wash off, okay. It thins out and it washes off due to high temperature. It reduces the viscosity to the extent that it washes off the once viscous grease. Another factor that affects viscosity is the fluid type. The fluid type determines if the fluid is going to be viscous or not, or if the fluid is going to be viscous at a certain temperature or not. The fluid type also determines. Terminal velocity. What is terminal velocity? Terminal velocity is the maximum speed attained by a body falling through a fluid when resistive force balances weight. Is the what? The maximum constant speed by a body falling through a fluid when resistive force balances weight. So when resistive force balances weight, the maximum speed attained by a body when falling through a fluid is known as what? The terminal velocity. Ensure you put that down in your notes. Factors affecting terminal velocity. We have size of the body, shape of the body, density of the body, viscosity of the fluid. All these are the factors that affect terminal velocity. Remember the key word in this definition of terminal velocity. It says when resistive force balances weight. This is the key word here. Resistive force balances weight. And factors that affect terminal velocity, they include size, shape, density of body, and viscosity of fluid. Stokes' law. Stokes' law states that for a small spherical body moving slowly through a viscous fluid, the viscous drag force is F equal to 6 pi. This one is the coefficient of viscosity, RV. Okay, so let's look at this relation, this formula of the Stokes' law. Okay, where this thing that looks like N is equal to the coefficient of viscosity, R here is equal to radius of the sphere, V here is equal to velocity, and that is the formula. You know what pi is. So Stokes' law is F equal to 6 pi, this thing that is like N, coefficient of viscosity. That's this thing that's like N, then ROV. All you have to do is times everything. Here now, you substitute everything into the formula, all the parameters that you were given, substitute them for this pi. You know what pi is in mathematics, 22/7. Then you times, then you divide everything by 7. Then you get the what? The force according to Stokes' law. So if Jamb want to ask you a question, they might not tell you go and use Stokes' law. They will just give you the question and they will provide coefficient of viscosity, they will provide radius, they will provide velocity. They will just provide the coefficient of friction, provide radius of the sphere, provide velocity, and they will ask you to find force. So if you don't know this Stokes' law, how are you going to find force? So anywhere you see coefficient of viscosity and Stokes' law, the formula is very easy. It's just times throughout. Force equal to 6 pi, then you times the rest thing together and get your answer. Shiki, now you leave there. Easy peasy. Application of Stokes' law. Stokes' law explain what? Terminal velocity of what? Raindrop, sedimentation of particles in fluid, and oil drop experiment. So these are what Stokes' law explains. Okay, velocity of raindrop. Okay, explains the terminal velocity of raindrop. Sedimentation of particles in fluid. You know what sedimentation is? When particles sediment, they settle at the bottom of the fluid. And oil drop experiment. You know the oil drop experiment. Who carried out the oil drop experiment in atomic theory? It was carried out by Millikan. So the oil drop experiment by Millikan. Okay. Now let's look at some exercises to test the knowledge we've acquired so far. Jamb must repeat questions. Question 38. A block rests on a horizontal surface. As the applied force increases, the block remains at rest until the force reaches 20 Newton. After which it slides with a constant opposing force of 15 Newton. What are the values of the limiting friction and the dynamic friction, respectively? Very easy question. It looks long, but it's very easy. Option A, 20 Newton and 15 Newton. Option B, 15 Newton and 20 Newton. Option C, 20 Newton and 20 Newton. Option D, 15 Newton and 15 Newton. Very easy questions. Remember, it asks you respectively limiting friction and dynamic friction, respectively. Drop your answer in the comment section. Question 39. A small sphere of radius 0.002 meter falls through a viscous fluid with coefficient of viscosity. Remember what I told you, that they will not tell you to apply Stokes' law. It's the parameters that are given to you. That's how you are going to decide if you are going to use Stokes' law to solve to get your answer or not. So this one is an example of the application of Stokes' law. So this is the coefficient of viscosity. If the sphere moves with a steady velocity, so this is not the velocity of the sphere, 0.01 meter per second, what is the viscous force acting on it? Viscous force. Find the viscous force now. A, 3.77 times 10 raised to the power minus 4. B, 3.77 times 10 raised to the power minus 3. C, 3.77 times 10 raised to the power minus 2. D, 3.77 times 10 raised to the power minus 1. All options represented in Newton. Drop your answer in the comment section.